All right, ready to dive into some seriously battle-tested advice for building software that lasts.
Absolutely, let's do it.
We're cracking open. Release it. Design and deploy production-ready software. This book is a goldmine of practical wisdom for anyone who's ever, actually had to build software for the real world.
It's one thing to get your code working perfectly in a nice, clean testing environment,
Right.
but out in the wild, with real users, that's a whole other ballgame. This book gets that.
It really does. And it kind of starts with this idea that, well, stuff's going to break, like no matter what you do.
Exactly, and that's where this whole recovery-oriented mindset comes in, which is a big theme in the book.
Okay, tell me more about that. What does that even mean, recovery-oriented?
So instead of trying to prevent every single failure, which, let's be honest, is impossible, you kind of accept that failures will happen, and you design your systems to be able to roll with the punches.
So it's less about, like, building an impenetrable fortress.
Right.
And more about, like, having a really, really good plan for when the inevitable earthquake hits.
Precisely. You want to minimize the damage. You want to get back up and running as quickly and smoothly as possible.
Because time is money, right?
Yeah.
The book throws out some pretty eye-opening stats about this. Like, one retailer was losing something crazy, like $100,000 every hour their system was down.
Oh, yeah, those numbers are real. High-frequency trading systems can lose that much in a single missed transaction. The stakes are high.
That's intense. So how do we start wrapping our heads around building these kinds of resilient systems? Where do we even begin?
Well, the book does a great job of breaking down what it calls stability anti-patterns. Think of these as like recurring danger zones in software design.
Okay, so like red flags to watch out for. I like it. Give us the rundown. What are some of these anti-patterns?
One of the most common ones is integration points. Pretty much every system out there relies on external services to some extent.
Sure, like databases, APIs, all that good stuff.
Exactly.
Wow.
But what happens when those services start acting up? Or worse, go completely offline.
It's like assuming your internet connection will never, ever drop.
Right. And then there's this domino effect. The book has this whole case study about TCP/IP connections and how even a tiny delay in an external service snowballed into this major outage.
Ouch. So it's not enough to just assume those external services will always be there working perfectly. We have to actually design our systems to be able to handle those hiccups.
Exactly.
Okay, so how do we do that? What are some practical tips for like making our systems more resilient to these inevitable integration point issues?
Well, a lot of it boils down to what we call defensive programming.
Defensive programming. So
Yeah.
like building in those safeguards, those backup plans.
Exactly. Things like circuit breakers, timeouts, decoupling middleware.
Okay, we're going to need to break down what those actually mean for those of us who aren't, coding ninjas.
Sure. So a circuit breaker is basically like a fuse box in your house. It prevents cascading failures by isolating a faulty service before it can take down the whole system.
Okay, so it's like containing the damage.
Exactly. Then you have timeouts, which prevent your system from hanging indefinitely, waiting for a response that might never come.
So you're not just left in limbo,
Yeah.
twiddling your thumbs.
Exactly. And then decoupling middleware. That's about designing your system in a way that if one part goes down, it doesn't take everything else down with it.
So each part is kind of operating more independently.
Mm.
Okay, that makes sense. So what's the next anti-pattern we need to watch out for? We've tackled integration points. What else is lurking out there ready to trip us up?
Let's talk about chain reactions. You know that classic domino effect? One little thing falls and it sets off this whole chain reaction.
Oh yeah, I've seen that happen with poorly stacked Jenga towers. Not pretty.
Exactly. In software, this can be just as disastrous. The book talks about this one scenario where a seemingly isolated resource leak on a single server.
Okay, so a slow leak, not a full-blown explosion.
Right, it snowballed into a complete system outage because everything was so tightly coupled. One weak link took down the whole chain.
Ouch, that's a tough lesson. It's not enough to just build things that work. We need to build them to withstand failures, to contain those failures. So how do we avoid creating these fragile domino chains within our systems?
Well, that's where understanding scaling comes in. And the book dives deep into the different types of scaling, horizontal and vertical. What works great with a handful of users in a test environment can completely crumble under real-world traffic.
It's like building a charming little footbridge that's perfectly adequate for a leisurely stroll, but then a crowd tries to cross it and disaster.
Exactly. That's why it's crucial to think about scaling right from the start.
Okay, so let's break it down. What are these different flavors of scaling? Give us the lowdown.
So you've got horizontal scaling, which is basically adding more servers to distribute the load. Like if that footbridge was made up of multiple smaller bridges all linked together.
So the weight is spread out more evenly.
Right. And then there's vertical scaling, which is about beefing up your existing servers. More RAM, faster CPUs, you get the idea. So it's less about adding more bridges and more about making the existing bridge stronger.
Okay, so two very different approaches. How do we know which one is right for our particular situation?
That's where it gets interesting. There's no one-size-fits-all answer. It really depends on the specific application, the type of traffic you're expecting, your budget, all sorts of factors. The book does a great job of walking through the pros and cons of each approach.
So we've got to choose wisely. No pressure, right?
Right. But the good news is, understanding these different scaling strategies is a huge step in the right direction. And then, of course, there's the wild card in all of this. Users.
Ah, yes. The unpredictable element. We can plan, we can test, but users always find a way to surprise us.
Tell me about it. They don't always behave the way you expect them to. Even something positive, like a surge in traffic, can bring your system to its knees if you're not prepared.
It's like throwing a party and suddenly twice as many people show up as you expected.
Right. And the book has this great example about a retail website that was completely overwhelmed, not by some malicious attack, but by their own email campaign. They were promoting pre-orders for a new gaming console, and they just weren't prepared for that level of interest.
Wow. Talk about a good problem to have, but still a problem. It's a good reminder that even success can be a stress test for your system. It's like, be careful what you wish for, right? You want your app or your website to be popular, but you better be ready to handle that popularity.
No kidding. Okay, so we've talked about external dependencies like APIs and databases and how those can be points of failure. And we've touched on scaling and how important it is to think about that from the get-go.
Right.
But there's another category of stability anti-patterns that we need to talk about, and these are the ones that happen inside your system.
Oh, okay. So like internal combustion versus getting rear-ended. Got it.
Something like that. So one of these internal anti-patterns is blocked threads.
Blocked threads. Okay, break that down for me. I'm picturing like a tangled up string of Christmas lights.
Not a bad analogy. So think of your system's resources as roads and threads as vehicles traveling those roads. When a thread gets blocked, it's like a traffic jam, bringing everything to a standstill.
We've all been stuck in traffic, not fun. What causes these digital traffic jams in our code, though?
Lots of things, but two big culprits are resource pool exhaustion and excessive synchronization.
Okay, I'm going to need you to unpack both of those, starting with resource pool exhaustion. What is that?
Imagine a bunch of threads all trying to use the same database connection at the same time. If you only have a limited number of connections available, some threads are going to be left waiting, right?
Makes sense.
And that's where the blockage happens. Those waiting threads, they're stuck, and that can ripple out and affect other parts of your system.
So it's like that multi-lane highway suddenly narrowing down to one lane. Instant bottleneck.
Exactly. And actually, the book tells this story about a caching system that brought down an entire website because of blocked threads.
Caching, like supposed to make things faster.
Right, exactly. But they hadn't really thought about how resource contention would play out under heavy load. They had all these threads trying to access the cache at the same time, and bam, gridlock.
Wow, so even when we're trying to be clever and speed things up, we can still shoot ourselves in the foot.
It happens all the time. Okay, so we've talked about resource pool exhaustion. Now, what about that other thread blocking culprit, excessive synchronization?
Yeah, what is that all about? Is it like when I try to sing along to a song, but my timing's totally off?
Kind of. Imagine you have multiple threads that need to access the same data or resource. Synchronization mechanisms, like locks, are used to make sure that only one thread can access that resource at a time.
Makes sense so far.
But if you're not careful, too much synchronization can create bottlenecks. Threads end up spending more time waiting for their turn than actually doing useful work.
So it's like having a bunch of cooks in the kitchen, but only one pot and one set of utensils. They're all just standing around waiting for their turn.
Exactly. It's a balancing act. You need enough synchronization to prevent data corruption and race conditions,
Right.
but not so much that it cripples your system's performance. And the book gives some great examples of how to strike that balance.
So we've got external dependencies, we've got scaling, we've got these blocked threads causing internal chaos. Anything else we should be bracing ourselves for?
Well, sometimes our own success can be our downfall, which brings us to attacks of self-denial.
Attacks of self-denial. Okay, that sounds a little too familiar. Like when I tell myself, I'm just going to have one cookie.
Right, exactly. But in software, this is what happens when your system gets so popular, so successful, that it basically collapses under its own weight.
Oh, wow. So it's like that restaurant that gets a rave review and
Mhm.
then gets completely overrun with customers they can't handle.
A perfect example. And often these self-inflicted attacks are triggered by something totally well-intentioned, like a marketing campaign that goes viral,
Oh, no.
or a new feature that everyone and their dog wants to try out.
Right.
The book actually mentions a case where a company sent out a promotional email.
Seemingly harmless enough.
Right. And their system was completely overwhelmed because they hadn't properly prepared for that kind of surge in traffic.
So it's like throwing a party and forgetting to account for like the plus ones and their friends and their friends' friends. Suddenly your house is overflowing.
Precisely.
So it's like you got to make sure your foundation is strong enough to handle the success of the party you're building on top of it. That makes sense.
Exactly. And this idea of understanding those constraints, those limits, it comes up again and again in the book.
Yeah, we've talked about that a bit.
And it ties directly into those scaling strategies we were discussing earlier, horizontal and vertical scaling.
Right. The whole more servers versus bigger servers dilemma.
Exactly. So horizontal scaling, adding more servers, it's like building a bridge with multiple spans, right? You're distributing the load, making sure no single point is overwhelmed.
Okay, that makes sense. But I imagine it's not as simple as just spinning up a bunch of new servers and calling it a day.
Oh, absolutely not. You've got to think about data consistency across those servers. You're dealing with distributed systems now, which come with their own set of complexities.
Right, right. So it's more like you're not just building a bridge, you're building a whole network of bridges,
Yeah,
and they all have to work together seamlessly.
exactly. It's a lot to wrangle. And then you've got vertical scaling, which is more about, like you said, beefing up your existing servers.
So like reinforcing the bridge you already have instead of building new ones.
Precisely. And that can be a great option in certain situations, especially if you have a more monolithic application that's difficult to break down into smaller pieces.
Okay.
But just like you can only make a bridge so strong before it becomes structurally unsound, there are limits to how much you can vertically scale a single server. Eventually, you hit a ceiling.
So it's about choosing the right strategy, or maybe even a combination of strategies based on your specific needs and constraints.
Absolutely. And it all comes back to that deep understanding of your system. You need to know where those bottlenecks are, those points of failure. You got to know what you're working with.
In the book, it gives you the tools to do that, right?
It really does. It's packed with practical advice and real-world examples. Like, it talks about how important it is to choose the right middleware for your system.
Middleware. Okay, remind me again what that is. Is that like the plumbing of your software?
Kind of. It's that layer of software that sits between your application and the underlying operating system, or between different parts of your application.
Right, right.
And it handles all the communication and data exchange between those different parts. So, it's pretty important.
Gotcha. So what kind of things should we be thinking about when we're choosing middleware?
Well, one big one is decoupling. The book talks a lot about the benefits of using decoupled middleware,
Decoupled meaning.
meaning that the different components of your system, they're not too tightly intertwined. They can talk to each other,
Okay.
but they're not completely dependent on each other to function.
So if one part of the system goes down, it doesn't take everything else down with it.
Exactly. It's all about building in those redundancies, those fail-safes, to make your system more resilient.
Makes sense. So we're choosing the right middleware, we're thinking about scaling, we're designing for failure. What else can we do to build these bulletproof systems?
Monitoring. You absolutely have to have good monitoring in place.
Monitoring, like keeping an eye on things, making sure everything's running smoothly.
Exactly. Imagine you've got this dashboard for your system, like the control panel of a spaceship.
Love it.
You want to be able to see all the vital signs, CPU usage, memory consumption, network traffic, all at a glance.
Right, so you can spot any potential problems before they become major meltdowns.
Exactly. The book emphasizes logging as well,
Logging meaning?
meaning keeping detailed records of everything that's happening in your system. Events, errors, performance metrics, all of it. These logs, they're like your detective's notebook, giving you the clues you need to figure out what went wrong and how to fix it.
So you can solve the mystery before the whole system goes up in smoke.
Exactly. And the sooner you can identify and address those issues, the better. It's not just about reacting to problems after they happen.
No.
It's about proactively preventing them in the first place.
Okay, so moving from a firefighting mode to more of a preventative maintenance mode. Gotcha. And I'm guessing this ties into the whole zero downtime deployment concept that I've heard thrown around.
100%. Zero downtime deployments, that's the holy grail, right? Being able to release new features and updates without any interruption to your users.
Yeah, like changing the engine on an airplane while it's still in the air.
A pretty apt analogy. It's definitely not easy, but the book talks about different strategies you can use to get there.
Like,
Things like blue-green deployments, where you have two identical environments and you seamlessly switch traffic between them,
Father.
and canary releases, where you roll out updates to a small percentage of users first to see how they do before going all in.
So you're basically dipping your toes in the water before jumping in head first. Smart.
Exactly. And it all comes back to that recovery-oriented mindset we were talking about earlier.
Right, planning for those inevitable bumps in the road.
Exactly. Building systems that can gracefully handle failures, that can scale to meet demand, and that can be updated and maintained without disrupting the user experience. That's what this book is all about.
It's about building software for the real world.
100%.
Well, I'd say we've covered a lot of ground today, from those common stability anti-patterns to the strategies and mindsets that can help us build more resilient systems.
We have a lot to think about.
A lot to think about indeed. To our listeners, if you're looking for a practical, battle-tested guide to building software that can stand the test of time, Release It is definitely worth checking out. It's packed with wisdom and insights that can save you a lot of headaches down the road. Until next time, happy coding.